Hello friends, in today's question, a water of volume 2 liter in a container is heated with a coil of 1 kilowatt at 27 degrees centigrade. The lid of the container is open and energy dissipates at a rate of 160 joules per second. In how much time temperature will rise from 27 degrees centigrade to 77 degrees centigrade? The specific heat of water is given as 4.2 kilojoule per kg. So in this case, we are going to make use of the formula which helps in finding out the increase in temperature, and that is our Q is equal to M multiplied by C and multiplied by delta T. And then we are going to find out the effective heat, because there is a loss of heat, and the loss of heat, or we can say loss of energy, is given as 160 joules per second. So we are going to find out the effective value of heat that will be used in raising the temperature. From that we can easily find out the time. So let us start with the heat required to raise the temperature. Heat required to raise the temperature, and that is given as Q is equal to M multiplied by C multiplied by delta T, where M is the mass, M is the mass of the liquid here in case of water, so mass of water, and we can calculate the mass of water. It is given as 2 liters, so this will be 2 multiplied by 1 kg per liter, and this will be giving us mass as 2 kg. C is the specific heat of the water, which is already given to us. C is the specific heat of water, and that is given to us as 4.2 kilojoule. So we can write it as 4.2 kilojoule per kg, and delta T is the rise in temperature. And which can be calculated as temperature initial and with respect to temperature final. We can say this is temperature final minus temperature initial. So we have 77 degree minus 27 degree. This gives us 50 degree centigrade. So we substitute the values and find out the value of Q. Therefore we can say Q is equal to mass is about 2 kg, and specific heat is given to us. Let us convert it to joule. That comes as 4200 and multiply by 50. This will be coming as 42 and 42000 joules. So this is the amount of heat required to raise the temperature. But because of heat loss, we are going to find out the effective heat that will be used for raising the temperature. So we say effective heating rate. Effective heating rate. And this effective heating rate, let us suppose we represent it as Q effective, which will be equal to P minus Q that is being lost. So P is given to us. P is our 160 joules per second, and sorry, the loss is 160 joules per second. Therefore, we can say that P will be equal to 1000 minus loss is given as 160, and this comes as 840 joules per second. Herein, P is the power that is being supplied to the coil, which is given as 1 kilowatt. So let me write it here. P is the power given to the coil. P is the power given to the coil, which is our 1 kilowatt. So that will be your 1000 watts. So 1 kilowatt, and this comes as 1000 watt. And finally, we can find out the time required to raise the temperature. Time required, let us suppose that is given as T will be equal to the heat supplied divided by the effective heat, and the heat supplied is our 420 and 000 divided by effective is our 840. So this comes as T is equal to will be equal to close to 500 seconds, and we can just convert this time, and that will be coming as 8 minutes and 20 seconds. So the options is A is the correct one. You can say option A is correct. Option A is correct. This completes the question. Thank you.